Determine if the series, the summation n going from 1 to infinity of n over n squared plus 12 quantity squared converges or diverges. Now notice that the terms themselves have an underlying function. F of x equals x over x squared plus 12 quantity squared is a completely reasonable function. And so we could go and check if the integral from 1 to infinity of the underlying function converges. That's the integral test right here. If it converges, then the series will converge as well. So let's check that out. So we want to go and do the integral from 1 to infinity of x times x squared plus 12 to the minus 2 once we have it prepped. So remember, infinity is a bad endpoint right here, so we're going to have to do this as a two-step process. We're going to take the limit as a tends to infinity of the integral that goes from 1 to a, the approximation point, of x times x squared plus 12 to the minus 2 dx. So the first thing we got to do is work this approximate integral, and then we'll take the limit. So let's find an antiderivative first. X times x squared plus 12 to the minus 2 dx is an excellent u substitution candidate. If we let u be the expression inside the parentheses, x squared plus 12, then du dx is equal to 2x. And so if we rearrange the terms, we would have du over 2 is equal to x dx, and that fits the integral. So making the substitution, we're going to have a 1/2 du for the differential, a u to the minus 2 is the function, and we're going to integrate that. So the 1/2 will come along for the ride. The antiderivative of u to the minus 2 is u to the minus 1 divided by minus 1. And so if we clean up, we have negative 1/2 times u, which was x squared plus 12 to the minus 1, as an antiderivative. So now to do the integral from 1 to a of the function x times x squared plus 12 to the minus 2, all we need to do is take this antiderivative, minus 1/2 times x squared plus 12 to the minus 1, and evaluate that from 1 to a. So if we plug in a, we're going to have minus 1/2 times a squared plus 12 to the minus 1. Then we're going to subtract negative 1/2 times 1 plus 12, or 13, to the minus 1. And then if we clean that up a little bit, that's minus 1 over 2 times a squared plus 12, plus 1 over 2 times 13, or 26. So there's our approximate area. Now we can go plug this into here and take the limit of that. So if we let a tend to infinity, we're first going to have 1 over 2 times infinity plus 1 over 26. The 1 over infinity term tends to 0, and so we get a 1/26. Therefore, the improper integral converges to 1/26. That means, according to the integral test, that the series converges as well. So by the integral test, the summation n going from 1 to infinity of n over n squared plus 12 quantity squared also converges. Note that I can't tell you what it converges to. I can simply show you that it converges as well. So this is an important thing right here. The summation n going from 1 to infinity of n over n squared plus 12 quantity squared does not sum to 1/26. The integral test tells you the area of the integral, not the sum of the series. It's worth pointing out that if we were to sum the series from 1 to 200, we would get a value which is larger than 0.04, and that's larger than 1/26. In fact, the sum of the series is almost always greater than the integral itself. So do keep that in mind when you use the integral test.